This is problem number 1 from analyzing linear functions. You can see we have an absolute value, that V shape that is pointing downwards. And in this lesson, we're going to take different terminology, some new and some you have seen before, and we're going to analyze this specific function. If you don't have this on your paper, please put that in. If it's not there, it'll be easier when we do this. So what is domain? By quick hand raise in this classroom, raise your hand if you've heard the word domain before. It's okay if you haven't. So most people have heard the word domain, but again, we're just coming off a pandemic. You may have forgotten what this means. It means we're going to assess this function from left to right. We're going to look at this function. We're going to see, is there any areas where it stops, or is it free to go all the way to the left and all the way to the right? Please make sure you're not talking. No cell phones out. Whenever you see a diagonal, the reason it's diagonal is because it's being pulled to the left at the same time it's being pulled down. So in this case, it's pulled to the left and down, and here it's pulled to the right and down. Why does that matter? Because when we're talking about domain, we're discussing x values. There's no limit how far this goes down as it's going to the left. I'm going to put here a D for domain. And there's no limit how far this is going to the right as it goes down. So there's no limit to the left or right. Well, how do I represent that with math symbols? When there's no limit how far it goes to the left or right, we represent it by going negative infinity to positive infinity. And there are parentheses on both sides. We can't actually touch the symbol infinity. It doesn't represent one number. It's an ongoing. This means it's ongoing to the left and ongoing to the right. Now, range is very similar. Instead of x's, we're talking about y's. We always do the small first and the large second. So let's start with the small. There's no limit how far down this goes. So no limit how far down it goes would be represented by negative infinity. And there is a limit how high it goes. It goes up as high as a y value of -4. It goes up as high as a y value of -4. And in fact, that point is part of this graph. It's part of the graph. I need to include it. Precision matters at this point in your math career. What do I mean by that? Well, if you put a parenthesis instead of a bracket, meaning we include it, it would be wrong. Okay, please do a self-assessment right now. Next to each one of these, you're going to put a smiley face or a frowning face. An example, hey, I get domain, but I'm confused with range. All right, the next two are similar, like domain and range are similar, and the next two, increasing and decreasing, are similar. So when you look at a graph, we are always going to do a couple things. Whenever we are evaluating whether it's increasing, decreasing, or constant intervals, three things we're going to do. So I want you to write these down, please. 3 things. One is we're always going to use parentheses whenever we talk about increasing, decreasing, or constant intervals. Always use parentheses. Second, always examine the graph from left to right. Always examine the graph from left to right. And lastly, when we examine it, we're going to be referring to the x values. Referring to the x values. Whether you are a competitive runner or you just enjoy simply going running. Do I have anybody who, I don't care how fast you are, anybody enjoy running in here? Awesome. Here we go, Eddie. So Eddie here, this is Eddie running, okay? There's Eddie, got it? So from left to right, how would you describe Eddie running right now? He's going what? Uphill. Would you guys agree from left to right he's going up? Uphill is increasing. Go on your paper and write INC for increasing. INC for increasing. Let's see if I can zoom this in for you. Does that help a little bit in back, guys? Okay. Now Eddie gets to the very top. And Eddie is exhausted. He stops, right? Now, when he stops at the top of the hill, he is not increasing, he is not decreasing, he's just resting, okay? So at this particular point, he's resting. This whole way he's increasing, and then he gets to rest. And again, guess what happens when he goes downhill? He is decreasing. Now, I'm going to show you how we can take this information and we can use math symbols and numbers to correctly represent this. So, the part that is increasing, I need to use just parentheses, so I'm going to put parentheses down so I don't make a mistake. I need to analyze it from left to right, I've already done that, and I need to state it in terms of x values. So if this part is increasing right here. In terms of x values, it comes from the far left. I represent far left with negative infinity. And it continues to increase until it gets to this x value. Why am I doing x values? It says it up here. Anytime we do increasing, decreasing, or later constant, we do it in terms of x values. So it continues to, again, it continues to increase till it gets to this point. What is this x value? It is 0.5. 0.5. Done. Where is it decreasing? It's decreasing over in this region. And it starts to decrease as soon as Eddie leaves the top of the hill. What is that x value? That x value is 0.5. And it continues to decrease as it goes to the right, not down. Remember, in terms of x values, as it continues to go to the right. To the right, endless is positive infinity. Remember, we're describing it in terms of x's, never in terms of y's. End behavior, before we talk about that, please put a smiley face or a frowny face. Never ever feel embarrassed, even if you watch the videos, to do a frowny face for all of these. End behavior is a way to simply describe the ends. So if there was a stamp, it would be awesome. It would look like this. So please make this on your paper. Every time they say end behavior, this is what we're going to start with. And I'm going to put up here, because you're just learning this, you're going to write left, and you're going to write right. So this will always be, for every problem that we are going to assess and behavior, this is like a stamp. You'd stamp this down every time. And we need to fill in this area. The answer to each of these will always be up, down, or it'll remain constant at one number. So let's check this out. If I went way over here, let me grab a highlighter. If I went way to the far left, this means x is to the far left. So I went way over here. And I was able to draw some type of an oval, and it went all the way up and all the way down. And I said, okay, eventually this line is going to intersect this area, right? Eventually this line will come in contact with this area I have in yellow. And when it comes in contact, so it's at the very end behavior, when it comes in contact, you are going to need to evaluate it. You're going to say, yes, this line is going down, it's going up, or it's staying constant at one number. Turn to your partner. What would you say? When this intersects this area eventually, would it be headed down, headed up, or staying constant? Tell your partner. The answer is it would be headed down. Well, how do I write down? Down is represented by negative infinity. Okay, let me draw a different color way over here. And if I could extend that orange oval all the way down and all the way up, and I ask the same question, okay, on the far right-hand side, eventually this will come in contact with this orange. And when it comes in contact, you're going to evaluate it. Is it headed down? Is it headed up? Or is it constant? The answer is it's still going down. And we represent that with a negative infinity. Now, I trust you've all learned about intercepts. So let's check this out. Here is the x-axis. And we can see this V shape never, ever, ever intersects or touches the x-axis. So how do you write that down? The most common mistake students make is they put 0. There's none. That's wrong. When you see a 0, that means the x-intercept would be 0, and we know it never crosses. So mathematically, please put a 0 with a line through it. That means none. It's a mathematical symbol you may have not learned. It means none. Or this pretty little curly brackets means none. There's nothing inside. It's called the null set. There's nothing inside. Now, if you put NA, there's none available. I wouldn't count that wrong, but that's not mathematical. These two are right. I wouldn't count this wrong. What you cannot put is just simply a 0. A 0 with a line through it is okay, but not just a 0. What is the y-intercept? I can see it crosses at 0, -5. The -5 is in the y place. Just like working with parabolas, when a parabola was opening up downward, I'm going to draw a quick picture like this. We knew that in that equation, ax² plus bx plus c, the a would be negative. And if it was opening upwards, the a would be positive, okay? That's the leading coefficient. Same here. We have an absolute value. Because it is pointing downwards, it tells me that the leading coefficient is negative.